Johan Kildal. I'm a researcher in Tekniker, a research center in the Basque Country. I specialize in interaction between people and robots, mostly. I'm an ESCI specialist. In the master project, I'm leading the research activity from the perspective of Tekniker. Right, in the master project, Tekniker is going to be developing some technologies, XR technologies. Specifically, we're going to be developing, designing, implementing, validating some tools to help people program robots using extended reality technologies. So our goal is for anybody to be able to program a robot without having to write any code. And for that, we're going to have interactive, intuitive XR technologies that they can use. My first thought was that it was a combination of this is going to be very exciting and this is going to be very demanding as well. It's exciting because this is very needed. So tools to learn about robotics and to be able to use robotics both in the education context but also in industry are very necessary. But that's going to be challenging because there's so much that can be done in that field. We're going to bridge the gap between real and virtual robots for training by using the same system architecture in both cases and also the same interaction techniques. So user that is interacting with the physical robot in a certain way will actually interact with its holographic digital twin exactly in the same way. And the system architecture in the background is also going to be the same all the time. The master project is going to develop XR tools in three very important areas of robotics. One of them is going to be safety and ergonomics of the interaction with robots. The second area is going to be programming of robots, creation of programs for the robot to execute. And the third area is going to be intuitive interaction methods to be used between the user and the robot. Well, that's possible because we're going to be implementing ways of interacting with holographic content as if it was physical content. So, for instance, users will be able to indicate a new configuration for a robot by physically placing it in space in a different way. So they actually grab the physical robot and move it, or identically they grab the hologram and move it. And in that sense, you can transfer knowledge, skills, and you don't need to write any code. It's going to be very helpful for industrial training in the sense that nowadays vocational schools, for instance, they do have some robots, physical robots, for the lessons, for the classes, for the practice groups, but they have serious limitations in the number of robots that they can have and the variety of robots that they can have. They cannot have every kind of robot in their premises. So with XR technologies, you can produce any robot in the market, and you can also recreate any production context that you can think of and let students practice. I hope and I'm sure I'm going to learn a lot about new ways of using XR technologies. The combination of XR with robotics is fairly novel, fairly new, and I'm really interested in it. I think I'm going to learn a lot about how to do that in the right way.